All right, hopefully you have your title, purpose, diagram, materials, procedure, data table all ready to roll. I will post an answer key for this over the weekend so you can check. I think my answer key is with those crossed off numbers though, just forewarning. My answer key is going to have math with those, but again, you can, as long as you understand the process, you should be fine. So calculation-wise, I balanced my chemical equation, and then I set up my BCA table. So I'm talking BCA table right here. The numbers that we have in our data table for the starting amount of calcium chloride and the starting amount of Na2CO3 were in grams. So up here is where I took my grams to moles. So this was mole island, so 0.77 grams of CaCl2, and I divided that by the molar mass of CaCl2, which is 100.98, so 1 calcium plus 2 chlorines. So 0.77 divided by 110.98 gave me 0.0069 moles. And then I did the same thing for the Na2CO3. So I started with 0.42 grams divided by the molar mass of Na2CO3 and got 0.004 moles of Na2CO3. So that's where this mole in blue and this mole started. I don't have any of my products. So minus 1x, minus 1x, plus 1x, plus 2x. And then over on this side is where I found my x. So I took my moles of calcium chloride divided by 1 and my moles of Na2CO3 divided by 1 because they both have 1s as their coefficient. The smaller one was 0.004, so that's my x value, and that makes this guy my superstar. So it's all about the superstar, so I plugged in that for everything. And what I really care about here is how much NaCl I should, in theory, based off my calculations, make. So I got 0.008 moles, and so I need to convert that into grams, so I'm going to multiply it by the molar mass of NaCl, so 58.441 Na plus 1 Cl. So 0.008 times the molar mass gave me a theoretical yield of 0.47 grams. So in theory, based off what I did in lab, I should have made 0.47 grams of NaCl. To find the actual yield, I'm going to take stuff from my data table. I'm going to take that final mass that I got when the beaker was all cooled and the salt was stuck to it, minus the mass of that empty beaker. So I take the mass I got at the end, what I actually made in lab, minus the empty beaker, and that got me 0.94 grams of an actual yield. To find the percent, I take the actual divided by the in theoretical yield from the BCA table times 100, and I got a 200% yield. That's a big yield, but we'll talk about that in the CER. So the next step is our CER, so claim, evidence, and reasoning. I'm actually going to fill it out on something different, and you should have this graphic organizer too. So I'm going to use this graphic organizer to help kind of organize our thoughts and ideas. The claim answers the purpose of the lab, and the purpose of the lab was to find the percent yield of NaCl. So I'm literally going to write one sentence straight out. The percent yield of NaCl is 200%. Evidence is any numbers that helped me directly get that 200. So the two numbers I used was to get that 200% was actual yield and theoretical yield. So my first piece of evidence, the actual yield of NaCl was 0.94 grams. My second piece of evidence is all about theoretical. The theoretical yield of NaCl was 0.47, and that was calculated from the limiting reactant, right? It's all about the superstar. So there are my two separate evidence, actual and theoretical. Both of those are the numbers I needed to calculate this 200%. Reasoning is showing that you actually understand what you did and the chemistry that we've learned. So the one that goes with actual yield, right? The actual yield was 0.94 grams, and we actually collected it in the lab. So the reasoning is that we actually collected this in the lab and we massed it. That's how we got this actual yield. The other one is where we talk about our knowledge of stoichiometry. So using the initial amount of limiting reactant, so it's all about the superstar, a balanced chemical equation, and stoichiometry, which stoichiometry is the BCA table, we found the theoretical yield. So you're telling me, how did you find actual yield? We measured it in the lab with a balance. How did you find theoretical yield? Well, in theory, we crunched some numbers using stoichiometry in a BCA table. So the last step is I asked for some sort of error analysis. So this is kind of like a wrap up couple of sentences with the reasoning. So here's kind of my tie it all together. Percent yield compares actual and theoretical yield. So that kind of ties these two ideas together. And then for us, our percent yield, we will use this fragment. The percent yield for NaCl was above but it could have been below, so that's an option, but ours was above 100%. That means our actual yield was higher than it should have been. Some errors that occurred. Well, what could have happened? In my mind, if that actual mass was bigger than it should have been, is it possible that I didn't actually dry all the water? Right? I was boiling off the water, but what if I took it off too soon? That could have happened, right? That would make the mass higher. Or what if I burned the salt? When we burn things, remember, oxygen comes and attaches. That would make the mass higher, right? So I'm going to just pick one of those. Let's just say I burned the salt. So some errors that could have occurred is when I was boiling off the water, some of the salt got burned, resulting in a higher mass than what was actually made, or should have actually been made. Errors that can be reduced in the future, I could boil the water at a lower temperature to reduce the risk of burning, right? I could have taken off the salt faster. I couldn't, instead of leaving it on there where it got burned. So that's what I would do next time to maybe not make my percent yield over 100%. Okay, I hope this helps. Use this outline, and if there's anything that you think, knowing that you have to do one of these on your own, that you think you should put on the back of your periodic table, I highly recommend doing that. Good work, guys.